Okay, now that we were able to establish the description of the behavior of a reciprocal function as x increases or decreases without bound, dumako naman tayo dito sa pinaka-ginagamit na klase ng function sa calculus, and these are our polynomials. Okay, so let's have a review or a recap regarding polynomials. And since we are still studying limits at infinity, but this time polynomials yung sasadyain nating klase ng function, okay, we will still use the n behavior of polynomials. Okay, so ang form ng isang polynomial function is f of x equal to a sub n x raised to n plus a sub n minus 1 x raised to n minus 1, okay, hanggang doon sa constant a sub o. So yan yung general form ng isang polynomial. Okay, yung a sub n dyan, ang tawag natin is the leading coefficient. Okay, since that is the coefficient of x containing the highest exponent, and that exponent is being described or being represented by the variable n. Okay, so yung n dyan, class, yan yung pinakamalaking exponent ng variable x natin. Okay, so kung nasaan yung pinakamalaking value ng n or yung pinakamalaking exponent for the variable x, okay, yun ang tinatawag natin na leading term for the polynomial. Okay, so meron tayo ditong idea regarding limits of polynomials as x increases or decreases without bounds. Okay, so the end behavior of a polynomial matches the behavior of its highest degree term. So anong ibig sabihin yan? Okay, so simpleng pag-intindi lang, class. Okay, ang ibig sabihin ng idea na yan ay yung magiging behavior ng isang polynomial ay kayang diktahan lang maski nung leading term lang. Okay, so for example, we have this polynomial here. Okay, sabihin natin we have the polynomial p of x equal to x raised to 7 plus x raised to 5 minus x raised to 4 plus 3. Okay, that is a polynomial of degree 7 dahil yung 7 ang pinakamataas na exponent ng variable x. Okay, by the idea that the end behavior of a polynomial matches the behavior of its highest degree term, ang ibig sabihin lang nun, class, okay, as your polynomial approaches positive or negative infinity, nagiging obsolete yung other terms. Okay, or yung nagmamatter na lang is yung leading term natin. Okay, since we are studying limits at infinity, sasadyain natin, class, that x increases or decreases without bound. So doon muna tayo sa isang side, that is if x is increasing without bound. Okay, so nandito yon, x is approaching positive infinity. Again, when we say x is approaching positive infinity, ang ibig sabihin lang nun, class, is you are approaching positive large numbers such as 10 million, 10 billion, 10 trillion, okay, whatever it is, basta numerically large siya, okay, and positive value. So ang gagawin natin dito para masatisfy natin yung condition natin regarding the end behavior of a polynomial, we'll just substitute large values of x into the polynomial and evaluate the value of the function. Okay, say x is equal to, sabihin natin, class, 100,000 or 1 million na lang. Okay, what is p of 1 million? O di ang gagawin natin, pasok mo na value ng x is 1 million. Tama ba? Or simply that's 10 raised to 6. Okay, 10 raised to 6 is 1 million, ha? 10 raised to 6 raised to 7 plus 10 raised to 6 raised to 5 minus 10 raised to 6, and then you raise it to 4 plus 3. Okay, para mas mabilis, di pasok na lang natin sa calculator. Okay, so that's x raised to 7 plus x raised to 5 minus x raised to 4 plus 3. And then, pasok mo na value ni x is 1 million or 10 raised to 6. Okay? So, the value of our polynomial is 1 times 10 raised to 42. Okay? That's a very large number. Tama? 1 times 10 raised to 42. Now, if we are going to adapt the idea that the end behavior of a polynomial is being dictated by its highest degree term, okay, di pwede nating sabihin, class, that x raised to 5 minus x raised to 4 plus 3 is obsolete. Okay, so tatanggalin natin yung ibang ibang terms at i-adapt lang natin yung leading term ng function or ng polynomial function. Okay? So, tatanggalin natin yung x raised to 5 minus x raised to 4 plus 3 at kukunin lang natin yung x raised to 7 being the leading term or the term containing the highest degree for x. Okay? So, ang ibig sabihin lang nun, ang magiging p of x na natin ngayon, class, is si x raised to 7. So, tinanggal ko na yung succeeding terms or yung ibang terms. Okay? What will be the value of p of 1 million using x raised to 7 only? Okay? So, pasok mo, that's 10 raised to 6 raised to 7. Okay? I think, class, this is 10 raised to 42. Tama ba? Since 6 times 7, that is equal to 42. Okay? Kapag 10 raised to 42, equal lang din yon sa 1 times 10 raised to 42. Tama? So, kung makikita nyo, o kung ayaw nyo maniwala, o di pasok na lang natin dito, class, baka nagdududa kayo, o x raised to 7, and then you hit calc, and then pasok mo 1 million or 10 raised to 6. Okay, hit equal sign, that's 1 times 10 raised to 42. So, nakikita nyo, class, that in either case, the value of our polynomial does not change. Okay, so 1 times 10 raised to 42, isali mo man yung x raised to 5 minus x raised to 4 plus 3, or hindi, still, the value of the function is approaching, or the function is approaching the same value. Okay? Pumunta naman tayo doon sa kabila. Paano if you are approaching the negative infinity? Still, we will apply the idea that the end behavior of a polynomial matches the behavior of its highest degree term. So, punta naman tayo sa left or sa kaliwa. Okay? That x is approaching negative infinity. Okay? So, we'll assume values just as what we did with x approaching positive infinity. Okay? So, tanggalin ko na muna to. Okay. Now, let us try values for negative infinity. Okay, so negative infinity, sinabi ko, class, that you are approaching negative numbers. Numbers which are numerically large, okay, in number or large in number, pero nagiging maliit because of the negative sign. Okay, so let us try p of 1 million. Okay, of negative 1 million. So this will be equal to negative 10 raised to 6, okay, raised to 7, plus negative 10 raised to 6 raised to 5, minus negative 10 raised to 6 raised to 4, plus 3. Okay, and then we'll input this in our calculator. Okay, so x raised to 7 plus x raised to 5 minus x raised to 4, and then you add 3. Okay, and then hit calc. Lagay natin 1 million or negative 1 million. So that's negative 10 raised to 6. So the value of our p of negative 1 million or the value of the polynomial as x is approaching negative 1 million will be negative 1 times 10 raised to 42. Okay, so sulat natin. That's negative 1 times 10 raised to 42. So what if we are going to adapt same idea for the values approaching negative infinity? So we'll try x raised to 7 lang. Tatanggalin na rin natin yung succeeding terms. Okay? So that's p of x equal to x raised to 7. Okay, so let us try p of negative 1 million. Okay, to represent negative infinity. And then, pasok mo siya dito sa function natin. Raised to 7. So, still, class, no? That's equal to negative 1 times 10 raised to 42. So, nakikita nyo na, class, no? That as we study the end behavior of a polynomial, yung succeeding terms niya nagiging void or nagiging obsolete. So, wala na silang naitutulong doon sa polynomial. It's just the leading term that dictates the behavior of the entire polynomial. So, yun lang yung tatandaan natin na ang magmamatter lang kapag nag-study tayo ng limits ng polynomial ay yung leading term. Dahil yung leading term lang naman talaga yung nakaka-apekto doon sa value ng buong polynomial. Okay? I hope that is clear with you. And let's start with our example. Okay? But before we formally proceed to our examples, I just want to clear these three limit notations that I have included in our module, okay, for limits of polynomials as x is increasing or decreasing without bound. Okay, so itong tatlong to, mababasa nyo to sa calculus books, including their graphs, if you are reading calculus books, okay? So yung unang class, that is the limit of x raised to n as x approaches positive infinity equal to positive infinity such that n is a positive integer. So kapag sinabi nating integer, those are whole numbers. Okay? Since that is a positive integer, then it could be 1, 2, 3, 4, 5. Okay? And so on. Yung pangalawa naman class, that is the limit of x raised to n as x approaches negative infinity equal to positive infinity, where n is a positive even integer. Okay? So, positive integer, yun nga lang, even. So, that's 2, 4, 6, 8, and so on. Okay? Yung pangatlo at panghuli, that is the limit of x raised to n as x approaches negative infinity equal to negative infinity. Kung kanina, even, dito naman sa panghuli, that is add. So, that's 1, 3, 5, 7. Okay? Actually, class, hindi mo yan kailangang i-memorize. Okay? Kahit sinong makakita niyan, maiintindihan nila agad kung ano yung ibig sabihin ng tatlong yan. Okay? Ngayon, hindi ko ina-advise na i-memorize nyo yan dahil dagdag pasakit pa or dagdag pasanin yan sa utak natin kung pipilitin natin siyang i-inject or kung i-integrate natin yan sa utak. Okay, so, ang gagawin lang natin, this is purely logical. Okay, titingnan lang natin yung magiging behavior ng isang function or nung mismong value ng function kapag ang i-input natin is positive or negative infinity. Okay? Okay, so what would be the value of x raised to 5, okay, as x approaches positive infinity? Okay, ang gagawin lang natin, isa-substitute natin yung infinity doon sa x. Okay, so this will become, okay, positive infinity raised to 5. Now, anong ibig sabihin ng positive infinity ulit class? Kapag sinabi natin positive infinity, ibig sabihin nun that is a number very large or very large in value. Okay, so pwedeng 10 million, 10 billion, 10 trillion. Okay, basta napakalaki niya. Okay, since positive infinity is a very large number and you are raising it to 5 or you are going to multiply positive infinity by itself 5 times, okay, di mas lalaki yung value ng positive infinity. Tama ba? And you can no longer determine the numerical value or you can no longer define kung ano na yung positive infinity raised to 5. Tama ba? Since positive infinity or negative infinity are not real numbers but they do define numbers which are large or small in nature, okay, then we can say that positive infinity raised to 5 is still equal to positive infinity. Okay, do you get it? So sabi natin, positive infinity is to represent numbers which are very large. Okay, ngayon, kung i-large number, i-raise mo pa siya sa 5, mas magiging malaki yung value niya. Or that you are still approaching positive infinity. I hope na nakuha nyo. Okay? What if we have x raised to 5, okay, as x approaches negative infinity? O di ipasok mo naman ngayon yung negative infinity for our variable x. So this will become negative infinity raised to 5. Okay, so anong magiging value ng negative infinity raised to 5? Actually class, okay, negative infinity is equal to negative 1 times positive infinity. Tama ba? Okay. Mas madali kasing mag-evaluate kung puro positive na lang yung gagamitin natin. Okay? So this will become equal to, okay, negative 1 times positive infinity raised to 5. Now, let us distribute our exponent. Okay? So negative infinity raised to 5 will become negative 1 raised to 5 times positive infinity raised to 5. Tama? Okay. Ngayon, sinabi natin kanina class that positive infinity is a very large number. I-raise mo pa sa 5 ang isang napakalaking number o di mas dodoble or hihigit na naman yung value niya. Therefore, you are still approaching a positive, you're still approaching positive infinity. Tama? So, positive infinity ang sagot for positive infinity raised to 5. Okay, ngayon pumunta tayo doon sa negative 1 raised to 5. Negative number, you raise that to an odd exponent. Okay, negative number pa rin yan. Tama ba? So, negative 1, imumultiply mo siya ng 5 beses. Okay, ang sagot ay isang negative number. Tama ba? Since negative 1 raised to 5 is equal to negative 1, tama? Then, ang magiging syntax nung sagot natin is negative 1 times positive infinity. Tama? So, negative 1 times positive infinity, that is equal to negative infinity. Okay? So, ganun lang class. Since positive infinity is a very large number, ngayon, nag-multiply ka sa kanya ng isang negative number, ike-carry niya yung negative sign nung number na minultiply mo sa kanya. Okay? So, instead of being a very large number, naging maliit siya because of the negative sign. Okay? I hope that is clear. Paano naman kung ganito? X raised to 4 as x approaches negative infinity. So, similar nung ginawa natin dito sa unang dalawa, i-substitute lang natin yung value or yung negative infinity for our variable x. So, that's negative infinity raised to 4. Again, class, negative infinity is equal to negative 1 times positive infinity raised to 4. Now, distribute our exponent. Okay, so that's negative 1 raised to 4 times positive infinity raised to 4. Again, class, excuse me, positive infinity is a very large number. Now, if you take the positive number 4 times, or imumultiply mo yung positive number ng 4 na beses doon sa sarili niya, edi mas lalong lalaki na naman yung value niya. Tama ba? So, positive infinity, you raise that to 4, you will still approach positive infinity or a number very large in value. Okay, so this will become positive infinity. Now, what is negative 1 raised to 4? Negative 1 raised to 4, that is positive 1. Tama? Kasi nga, minultiply mo ng 4 na beses yung negative 1 sa sarili niya. And if you raise a negative number to a positive odd exponent, okay, or sorry, to an even exponent, okay, nagiging positive na yung nature niya. Tama ba? So, negative 1 raised to 4, that's equal to positive 1. Ngayon, positive times positive, so malamang ang sagot natin ay positive. Okay, so that's positive infinity. So, ganun lang naman yun, class, yung ibig sabihin ng tatlo. Okay? You need not to memorize those 3 limit notations. You just have to evaluate or simply tignan mo na lang yung logic, okay, behind those 3 notations. Okay? So, ito yung gagamitin natin for our examples. Substitute mo na agad yung positive infinity. Or yung negative infinity. Basta ang tatandaan lang natin, class, okay, na kapag nire-raise mo ang positive infinity, mas lalong lumalaki yung value niya. Or kapag nire-raise mo naman ang negative infinity, mas lalong lumiliit or lumalaki yung value niya. Depende doon sa nature ng exponent na gamit mo. Okay? So, let's start our example for limits of polynomials as x is increasing or decreasing without bound.